the process of benchmarking your own system using a model. I'm going to do this, step by step. Let's imagine a scenario where I want to have a model that generates responses to emails. Okay, we're going to be using this for the rest of the talk, and also the demo is going to be exactly that scenario. What I would do is the following steps. I have a data set of emails, okay? I could also generate this data set of emails. I will choose a model for my system. Let's assume right now the system is pretty basic and we're only trying to generate a response for a mail. We're not triggering subsequent LLM calls. We're not doing anything funny. We're not working with a database. That's all we're doing. Simple context, simple prompting, one model. The second thing that I have to choose is a metric, okay? I could choose something like accuracy, okay? But since, again, we're dealing with a much more complicated set of models than we used to have in the past, a lot of times the metrics are going to be a step up. There can be things like toxicity, fairness, bias, things like relevancy, which is what we're going to choose here for our scenario. We want to figure out if the responses that the model is generating are relevant to the original mail that we're asking it to generate a mail for. Third thing is we're going to create the benchmark. We're going to take our model. In this case, we chose Llama. We're going to generate for every email the response. And the fourth step will be to evaluate the benchmark for the metrics. So what does this mean? We have a column, and I'll show this in a moment on a slide. We have a column for the emails themselves. We have another column for the responses. And then we're going to have another column where we're actually evaluating. The evaluation can be done either by humans or by an automated model. So you see here, there's GPT-4 and humans. The reason I list GPT-4 is because a lot of the times people tend to use the stronger models in order to evaluate. They are more expensive, but they're obviously better at evaluation. And since you're not doing as much evaluation as you're doing production work, or given the fact that you can use models such as GPT-4, which again don't meet all constraints in terms of latency or working in an air-gapped environment and so on and so forth, it makes sense. Once you've done these 4 steps, you're good to go. Okay, you have a benchmark, you're able to evaluate a specific metric. Obviously, you don't have to limit yourself to one metric. You can do several. Then what you're going to want to do, or what I'd recommend, is you have to decide whether you're measuring precision or recall. See, which examples have actually failed, extract those failures, and try to drill down. Try to find out why the system didn't get it right. Is it the model? Is it the prompt that you're using? Is it, I don't know, an example which the model thinks is wrong, but actually when you're looking at it is right? Again, here you don't have to do this until everything is right. You also don't want to overfit your model, but you definitely want to spend some time after benchmarking, drilling in and improving your system. So steps 5, 6, and 7 would be improving your system. Great. Let's go through this before we jump into the demo. I want to remind everybody, what we're doing is we're creating a system which generates mail responses in relation to a mail that has reached us. First thing, we need to choose a metric. There are a lot of metrics to choose. It depends on the use case. It depends on what you care about. Q&A, RAG, relevance, hallucination, fairness, robustness, bias, toxicity. You can invent your own metrics. You can be smart about how you're measuring it. Just another example, sometimes you want to tell the model to answer concisely. One very simple way to measure whether the model is answering concisely is if the answer is short. If it's, if you're telling it to summarize, another example, and the summary ends up being longer in length, which is, just measuring the number of the length of the string or the number of tokens, then it's probably not doing a very good job at summarizing. Benchmarking process. Again, we have the emails. you could have generated them with a model. You could have handwritten them. You could have downloaded a data set from the internet for the emails. Next, you have to generate the email responses. This is already our system. So for that, I'll be using Llama. Here are some email responses. By the way, the examples here are not real. I just wanted to, make something short that would be obvious. And then I have to decide what metric. So here I'm just measuring toxicity. Again, I will be using a stronger model. So I'm using ChatGPT and very basic, not real examples, but telling examples. You can see that the two on the bottom, the responses are quite toxic. That's why we have high toxicity on the second and third email, and the first one is not as bad, so rather low. At this point, we have to decide what we're measuring, precision or recall, and then this again ties into the business use case. Here, it's a place where which I just gave an example of churn of users, and the churn is very negatively priced, so you lose 600 for every false negative. So you're gonna be, just in this example, you're gonna be wanting to minimize the false negatives, which is why we'll be trying to maximize recall. But again, you have to think about your case. You have to map it out. You have to sit with the business function and understand how your system is going to be affecting production, or is going to be affecting your bottom line, if it will be. So as you can see, the two bottom answers, they have some curse words, so they're rated high on toxicity. I'm going to drill in down to this. I'm going to see that. I'm going to realize, my prompt was not very good. I didn't actually remind it not to use toxic words, or I didn't I didn't do all kind of other things that I can do in order to curve the behavior. So I go ahead and I change the prompt template by doing some prompt engineering and run the test again. And now you can see I'm doing better. I'm not getting as many bad toxicity flags. Another alternative could be that the model is still not good enough, and having already changed some prompt engineering, I can obviously do that more, but I can also change the model here. I can also realize, Zephyr actually performs better, and you see just a fictitious example, I changed it and now it's performing much better. It begs the question, since I'm using a model to evaluate a model, how can this actually be? So first of all, there's an interesting paper here, and you can see the bottom line on the right in the graph, that a lot of the times models perform better than humans. We know this with medical use cases. We've been told that for quite a couple of years, that every now and again, there's a new benchmark where models actually perform better than doctors. Palm 2 recently passed the test for actually being a doctor in the US. There's no one silver bullet for why we can do this, but a very good way to think about it is the following. Perception is easier than generation. So generating an answer is not as easy as looking at something and saying, oh, yeah, this is good or this is bad. And by the way, this also applies to humans. If I ask anybody to write a Shakespearean play, it's not so easy. But if I gave somebody else your would-be Shakespearean play, it will be quite evident, unless you've studied and read quite a bit, to realize, this is not a real Shakespearean play. The same applies for models. Another way to state this is, we've been evaluating human intelligence using human intelligence, so it should hopefully translate into models. And two kind of last points to drill this home is generation requires quite a lot of planning, which is not easy. And we can perceive one property at a time, But when we generate, we must take them all into account. I'll give an example of that. I'm telling the model to be concise, to use all of the information from the mail itself, to not be toxic, so on and so forth. I give it quite, a comprehensive list of constraints, and it has to balance all of these out. And it's not so easy. Also, obviously, some of these can be contradicting constraints, which I wouldn't want to give it, but just to take the example to the extreme, it has to balance all of these out, and balancing them out is way harder than just, was the language toxic? Was it fair? Did it have a bias? I'm asking a very simple question when I'm measuring, but when I'm generating, I'm telling it to meet all of these constraints at once. Here's another example. This is one that I like from GPT, where it's not able to follow the instruction. You're telling it to start the sentence with an adverb, and 3 out of 4 times it manages to. This is not a very complicated task, but it's not going to be perfect, and evaluating this is very easy. Okay, even GPT-4 can evaluate this. When you ask it, is great guy an adverb? It will know that it's not an adverb. We are nearing the end. I just wanted to give you a small list. If you actually plan on doing this at home, there are a lot of tools that can help you do this quicker. Guidance from, I believe, Microsoft, Phoenix from Arise, DeepVal from DeepChecks, Ragus, which is an open source. This is more for like RAG systems, which we haven't discussed today, and Langsmith, which it's getting there. It's being built more and more features, even though it's still in beta. To summarize, we really recommend that you test. When we work with customers, this is obviously one of the first things we do, whether we're prompt engineering or if the customer already has done the prompt engineering and we're trying to optimize the use case in production, we're going to be testing quite a lot, very similar to how we test or why we test software. We believe this is necessary. Find the metric or the property, and also find a way to measure it, potentially measure a few properties, take them all into account, follow the process that I outlined here of recall and precision. And our recommendation would be to start with a model evaluating your system for the reasons I mentioned before.